we have two charged points now. Okay, two charged particles, Q1, Q2. They are placed 30 centimeters apart. Immediately we know we must convert the centimeters to meters. That's the very first thing you are going to do. Okay, as shown in the diagram, the point P is 10 centimeters to the east. So in other words, the distance between Q2 and P is 10 centimeters. Okay, define the electric field at a point in words. Okay, so we go back again. Remember, there's two definitions for electrical field. The one in a region or the one in a point. So the one at a point is the electrical field at a point is the electrostatic force experienced per unit positive charge placed at that point. And this is the formula we use there. Okay? Okay. So now calculate the magnitude and the direction of the net electrical field at the point. Okay. So keep in mind this formula, E is equal to F times Q. Okay. Keep in mind that. That is the formula we can use. All right, so in this case, because it is a straight line, okay, because it is a straight line and it's not part of the previous question, we cannot use this formula. Because remember in our previous example, what did I want to show you here was we used this because we used the 3-point system, because we already had FNet, okay? But here, we cannot use FNet because we are using a different system here. We're using the straight line. So first of all, we need to draw ourselves an electrical field diagram. So there's point P, okay? So that's a negative and P will be a positive according to our definition. So P will be attracted by force Q. So this will be the resultant electrical field caused by Q2 towards Q2. So that is P. And then for Q1, it is a positive. So P is also positive. So Q1 will push P away. Okay, so this will be the force caused by Q1. Immediately we put in our signs. We say this side will be positive, that side will be negative. So we will say then the electrical field net is then equal to EQ3 2, sorry, where am I getting the 3 from? Plus EQ1, and this will be a negative. All right. So what you can do now, you can work it out separately and then put it in to get the net field, or you do the whole calculation in one. Okay, so I'm just going to show you quickly what I did here. So there is our question. Okay, so we have now E net is EQ1 minus EQ2. All right, so they worked it out together. So the EQ2, they put on the other side to subtract. We just have it on this side, so we already also said it was negative. Okay, so there is our 1. So it's Q 1 centimeter, 10 centimeters, and this one is 30. So 30 plus 1, 30 plus 10 gives me 40 centimeters. So P from Q1 is 40 centimeters. And then we get our answer, which we have. Okay, what does the negative mean? Okay, what does the negative mean? It means that the net field will be going in the negative direction, so it will be going to the left-hand side. Okay, that's very important just to remind yourself. So it's going left, that's what the negative is. So the net field is in that direction, E net. Okay, any question, guys? So remember, the negative means you're going to the left. Yes, who's this?
Sir, can you please re-explain the diagram?
The diagram.
How you got
This
the
one.
values, the diagram? No, sir. On the previous page.
This one. Komotsu.
This one.
Baktumelu. This one.
Sir?
This one.
Yes, sir.
Do you want me to explain how I got this force diagram?
Yes, sir.
Okay. Go back to that. Okay. So there is my original question. Okay. So there is Q1. Okay, Tumeli, you can put off your mic. There is Q1. Then there's Q2 and Q3. Okay. Now Q1 is positive, Q2 is negative. So there's an attraction. Okay. So the force will be towards Q2. All right. Q1 and Q3 is the same sign. Same one. So they will be a repulsion force. Okay. So if we now go and draw the force body diagram again. Okay. So there is Q1. Okay. So Q1 is now attracted towards Q2. So the force that is applied by Q2 is an attraction force. So this is Q2, the force caused between Q2 and Q1. Then, if we go and look again at this one, between Q1 and Q3, there's a repulsion. So it's repelling it away. So it will go in the opposite direction. Will not go towards Q3. Okay? So in other words, Q1 will be pushed away from Q3. So this is then FQ3. Okay, but now we need to get the net force. All right, so the net force, this is the diagrams you've learned in grade 11. So remember, it doesn't need to be according to scale. So the net force will be the force caused by Q2 and the force caused by Q3 together. And we use the parallelogram method. And we get the net force as this. F net. Okay. Tumelu, fine with this? Tumelu?
Ja. Okay.
Tumelu, do you have any questions still? Okay, it looks to me Tumelu is not. Tumelu, are you still there? He is, I can see he's still here, but he doesn't talk. Okay. Are you happy with the diagram, Tumelu? It seems to me he's happy.